Okay, the variance is in square units, but note that the data values are not. So by squaring all the data values in step 3, which is what you did in the third column, you're squaring the units as well, which means that if your data values were initially measured in inches, the sample or population variance would be in square inches, because when you have a data value in inches and you square that data value, then you have inches squared as your units. And then you calculate the variance, and your units for the variance are square inches or inches squared. So square inches, inches squared, they're both the same thing. This is what your variance is specified in, the units for your variance. However, it's not the units for your data values. Since the unit measurements for the variance and the data values will always be different, so if given inches, you'll have square inches in your variance. If given feet, your variance will be in square feet. If given yards, your variance will be in square yards. Okay, if given pounds, your variance would be in square pounds. For that reason, it may be difficult to use and interpret the variance as a measure of variability. So, we like to have measures of variability to be in the same units as the data values that we had initially. So if our variance is in square units, but our data values were in just plain units, how do we go back and turn the variance to have the same units as the initial data values? So how do we undo the square units of the variance? And we can undo a squaring process by taking the square root. So if we take the square root of the variance, we get a new number, and this is the third measure of the third measure of variability, called the standard deviation. This is the most popular measure of variability. What we have to do to get the standard deviation is we first get the sample variance, and then we take its square root, and that gives us the sample standard deviation. Same thing with the population. We first take the population variance, then we take its square root, and that gives us the population standard deviation. Now notice the two symbols that we use for each. Where the population variance was denoted by sigma squared, the population standard deviation is denoted by sigma. While the sample variance was denoted by sigma little s squared, the sample standard deviation is denoted by s. So it really is the same exact calculation as before, but we have one more step, which involves taking the square root. So in our previous example, we found the sample variance s squared to be 6.6667. So the sample standard deviation would just mean take the square root of 6.6667, which becomes approximately 2.5820. I'll show you how to do this on the calculator in a minute. Also in the previous example, we found the population variance, sigma squared, to be 41.6. If we take the square root of that, we get 6.4498. And like the population, like the variance, we're going to round the standard deviations to 4 decimal places. So here's how we use our square root key on this calculator. Square root is in blue above the x squared key, which means you have to use your second key to access it. Second, and use your square root key. And then underneath that square root, you're going to type 6.6667. There's your sample variance, but when you hit enter, you will get your sample standard deviation. Okay, I think I have a typo here. 2.58. Oh no, this is okay. I'm sorry. 2.58199. Because I have a 9 in the 5th place, I have to turn that 19 into a 20, and that's where the 2.5820 comes from. It's good. Now if we do the next one, second square root, and we type in 41.6, hit enter, 6.4498, there's a 0 in the fifth place, so you could leave that as a 98, and that's good. Okay, so what does the standard deviation tell us? Because I've just gone through a process of how to calculate it, but I've not really talked about what it means so much. The standard deviation is in the same units of measure as the original data values. So if the original data values were in inches, the standard deviation is also in inches. Deviation from the mean is a measure of how far a data value is from a mean. So for example, if I take a data value x and I subtract the mean from it, the sample mean or the population mean, I get basically a difference that indicates how far that data value lies from the mean. So a data value could, if the mean were right here, a data value could fall to the left of the mean, which means it's smaller than the mean, and the degree or how far it falls below the mean is basically its deviation from the mean. Now, for all the data values in a distribution, the standard deviation is the average or typical deviation from the mean. So we started with a very small distribution, only 4 data values. We found the mean to be 6, and for a data value of 3, if the mean is 6, then 3 is on the left side of the mean, and it has a deviation that's represented by this length here. If we look at the data value 7, it has a value that is on the right side of the mean, with a distance approximated by this. And we could do the same for 5 and for 9. Those were the 4 data values in our initial distribution. Now, if we take all of these deviations into consideration, the typical deviation came out to be 2.5820. This is a measure of the variability of the data set. So a measure of variability is basically a measure of how variable our data set is. So 3, 5, 7, and 9 have a measure of variability of 2.5820. So this is a number that describes how variable a data set is. Now, at this point, I really am more concerned with you understanding how to calculate the standard deviation. And in the next lecture, we're going to discuss more about how to use the standard deviation and what it actually means. If you're completely unclear on that right now, it's okay, because we do touch more on that later. But after this lecture, you should be able to calculate the standard deviation and the variance without too much difficulty. And that is this lecture. So at the next lecture, we're going to discuss more about the standard deviation. And if you have any questions, you can email me. I'll see you then.